Fine. Now, what should we do to establish a network that will work on IPv6? Okay. Now, see, I'm just going to draw two network diagrams. One will be based on IPv4 and second will be based on IPv6. Clear? Okay. Now, as per your knowledge, you are comfortable to establish a network that is based on a star topology? Fine. And again, there is a network. What is this? Hub or switch? But now in these days, hub is not used. That's why it is a switch. This one is switch 1 and this one is switch 2. Now we have to connect 4 nodes with each switch. First node, second node, third node. We can connect any node at any port. Fine. So there are 4 nodes, same, first, second, third, and fourth. Fine. Now, these nodes are physically connected, but there is no identity of any node. All PCs are working well. OS has been installed, all applications are running, all drivers are present. Now we have to give them logical IP. This network will be based on IPv4 and this network will be based on IPv6. Fine. Now, decide about this network. Give me any network from class A, B, or C. Yes. 192.0.0.0. Last one. Okay, fine. 192. You are taking this value 192, and 192 belongs to class C. Okay, good. Class C. This is 192. Means these first three values will represent a network, because in class C there are 24 bits to represent a network. Is it clear? Fine. Network decided. Now in this network, the very first IP will be 0 and the very last IP will be 192.162. Sorry, I mean 0.0.255. Fine. So we cannot use this IP address. We cannot use this IP address also. Correct? Then the valid IP range is 192.0.0.1 to 192.0.0.254. From this range, we can take any IP address and we can assign it to these nodes. Fine. Now the default subnet mask. .255.255.0, because this is class C. Fine. You all have decided this network. Now we have to just put an IP address. Can I write here 192.0.0.1? Then 192.0.0.2, and subnet mask is there. 192.168.0.3, 192.168.0.4. Fine. Now, give me second network. Yes. Yes, 193.0.0. Fine. Now, again, same is story. 0, 193.0.0.1, 193.0.0.254, and 193.0.0.255. Subnet mask will be same. 255.255.255.0. Valid IP. Why I have taken the second network? Because in case if you are going to change the IP address of these two nodes, I'm just going to put another 192. Sorry, I have written 68 here. 0, 0. 193.0.0. For example, 3. 193.0.0.4. Then what will happen? If I will change the IP address of these two nodes, then what will happen? These two nodes will communicate with each other, and these two nodes will communicate with each other in second case, because there is a network change. And in first case, all these nodes will communicate to each other. Is that clear? This is the meaning of different network. Point is clear to everyone or not? Fine. Now, we will do the same thing, but with the help of IPv6. That's why I have drawn second network architecture. Now, here we have to decide IPv6 address. In IPv6, by default, first 64 bits are used to define network, and last 64 is used to define different hosts in a network, right? Because it is based on total 128 bits. Fine. So, for first network, just I am going to take value 2000. Just I have 2000. Then 0 dot, sorry, 0 dot, 0 dot, not 0 dot 0, 0 0 0 0, then 0 0 0 0, then 0 0 0 1. Fine. This is the network part. For 64 bit, I have taken 4 groups, and in each group there are 16 bits. That's why total 16 into 4, 64. The first 64 bit is used to define a network. So we have defined network. Fine. Now in this network, the very first IP will be 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4, and the very last IP fine, network part, and the last value f dot f dot f dot f. Fine. This is the first network. Now from this first network, I am going to just put value for these 4 nodes. How we will change the value? We will start from this group. 4 times 0, the next value will be 3 times 0, 1. The next value 3 times 0, 2, 3 times 0, 3, 3 times 0, 4, and so on. Fine. So this is a very long IP address. That's why I'm going to write the last value on this. Last value will be dot 0 0 0 0. This is also applicable. The very first IP is also applicable because all IP addresses in IPv6 network are valid host IP addresses. There is no concept of network IP and broadcast IP. Fine. That's why we can use it. Getting? So the next value will be dot 0 0 0 1, dot 0 0 0 2, dot 0 0 0 3. Fine. We have taken one network. We have assigned IP address to these nodes. Fine. As we have taken second network value in case of IPv4, so we will do the same thing for IPv6 network also. Now the second network, suppose 2000 colon 1 2 3 4 dot 1 2 3 4 dot, we can take 0 0 0 2. And the very first IP 1 2 3 4 dot 1 2 3 4 dot 1 2 3 4 dot 1 2 3 4 2000 colon dot not dot, colon, colon. I am missed. Colon. Okay. Colon. Find 2000 colon 1 2 3 4 colon 1 2 3 4 colon 1 sorry 0 0 0 2. Now this is the network part. This is the network part. The last value 1 2 3 4 colon 1 2 3 4 colon 1 2 3 4 colon 1 2 3 4. Fine. Again, I'm going to make some changes with these two nodes. Now at this time, I will put value 2000 colon 1 2 3 4 colon 1 2 3 4 colon 1 2 3 2. Then this is too long. Yes. Again, it is okay. 1 2 3 and 2. For second node, 2000 colon 1 2 3 4 colon 1 2 3 4 colon 1 2 3 2 1 2 3 4 colon 1 2 3 4 colon 1 2 3 4 colon 1 2 3 3. Fine. Now, same case should happen here. Same case should happen here, right? First network is based on and second network, right? Okay. I think you are getting. F because this is the last value. I have written here 255 because this is the last value. We have done exercise, no? Like serial number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9, 1, A, 1, B, 1, C, 1, D, 1, E, 1, F, and again 2, 0. Clear? Now, see, this is only long IP address because it has 128 bits and it has only 32. Fine. And in all these cases, we will use subnet mask 255 255 255 0. But in this case, in IPv6 case, we have to take only subnet prefix length. And that subnet prefix length is by default subnet prefix length of IPv6 is 64. Because it is similar to subnet mask. In subnet mask, all network bits means all ones are represented in decimal value. And in case of IPv6, so on network bits are represented in counted figure. So there are 64 bits. That's why we should write 64 as a network prefix length. Suppose we have to write this value, subnet mask value, in as a subnet prefix length. Then what should we write here? How many network bits are there? No, or not only 3. Network bits. 24. So that's why if we will use subnet prefix length, then in that case we will write here 24. But this is not applicable for IPv4. Here also 24. Here in all cases 24. But in case of IPv6, it will be 64, 64, 64, 64, everywhere. 64, 64. Fine. Any doubt? Anybody has any doubt? Just note down. Note down it properly. So please note down it, and I'm going to mark your attendance. We will see this diagram on with the help of Cisco packet system. Okay, because without ping there is no completion.